Hello there. Sorry, I am not here again today. My daughter is now sick, and it's my turn to stay home with her. So here's what we're going to do. We are going to skip the day 3 notes for today, just because those are a little trickier, and I'd rather be there to teach you. So we will do the day 3 notes together tomorrow. So right now you should have the day 4 notes open, and then we'll do day 3 tomorrow, and then don't forget we'll review on Thursday, and then your test is on Friday. So just a heads up with that. Dilations. All right, a dilation is going to be an enlargement or a reduction of a figure. Okay, orientation, so the way that it's facing, is preserved. However, congruency is not. We're going to be making stuff bigger and smaller, so obviously it will not be the same size when we are done. Scale factor is going to be the ratio of sides of two similar figures. Okay, so similar figures just means they're the exact same thing, just one's a tinier version or one's a bigger version. Now it says identify the scale factor that takes A to B. The order is going to be important. So we want to know basically what are we multiplying A by in order to get to B. So if we're starting with something that's 8 units and now we're ending up with something that's 3 units, we need to figure out what that scale factor is. So here's what we're going to do. We're going to do, obviously A is 8. 8 times S, that's our scale factor. We want to know what we're multiplying 8 by to get 3. And then all you do is divide by 8. Your scale factor is going to be 3/8. You can leave it as a fraction. You don't need to convert it to a decimal. Just make sure it's reduced, but otherwise you're good to go. And that's it. So if you multiply the first by 3/8, you will get the second one. All right, from A to B. So if we're starting with 4, 4 times what will get me to a size 6. Divide by 4. Your scale factor is going to be, reduce it 3/2. Use math frac if you need to, but definitely make sure it's reduced. So you get 3/2. All right, we're going from A to B. So we're doing 1 times something equals 1/4. Divide by 1. Your scale factor is going to be 1/4. All right, so not too bad. Okay, so now we get to the graphs. Okay, notice with number 4 we have x, y, arrow, and then it's 3 times x, 3 times y. So all we're doing is taking the x, multiplying by 3. Taking the y, multiplying it by 3. So let's write down our original points. So g is at -1, 2. You want to make sure you get the originals correct, otherwise your new ones will be off. 2, 0, and then m is at 0, -1. All right, we're going to multiply the x by 3. So -1 times 3 is -3. 2 times 3 is 6. We'll plot that in a moment. 2 times 3 is 6. 3 times 0 is 0. 0 times 3 is 0. -1 times 3 is -3. All right, we're getting 3 times bigger, so when we're done plotting these points, we should end up with something 3 times bigger. All right, when you're plotting these, don't forget to label them, U prime, G prime, M prime, and then connect them all together when you are done. Since this is getting bigger, it's an enlargement. Now the scale factor is going to be 3. Okay, it's getting 3 times bigger. All right, for the next one, we've got x, y, arrow, 1/2 x, 1/2 y. So this time we're taking x and cutting it in half, and same thing with y. So we're going to be making it smaller this time. And so C is located at -4, 2. A is located at 2, 6, and T is located at 8, 4. All right, and so then we're going to cut it in half. Half of -4 is -2. Half of 2 is 1. Half of 2 is 1. Half of 6 is 3. Half of 8 is 4. And half of 4 is 2. And so we're going to plot those. -2, 1 is C prime. 1, 3 is A prime, and then 4, 2 is T prime. Connect those points together, you can definitely see it got smaller, and again our scale factor is whatever we're multiplying by, which in this case is 1/2. Alright, so that's kind of how that works. If it's going too fast in the video, obviously pause it. I'm just, I'm stuck to a certain time that I have to stick to, and so if you needed to slow down, just pause it. Okay. For number 6, dilation maps 5, 4 to 15, 12. All right, so we got to figure out what the scale factor is, and then we'll apply it to this point, -2, 3. If you look at 5, 4 to 15, 12, we're going from a 5 to a 15. We're going from a 4 to a 12. You have to figure out what you're multiplying by. It's always going to be multiplied by something. You have to figure out what you're multiplying by to get to that new number. So 5 times what is 15? 4 times what is 12? They should be the same number. We're multiplying by 3. All right, 5 times 3 is 15, 4 times 3 is 12. So what we're going to do is with this new point, we're going to do the same thing. We're going to multiply by 3. -2 times 3 is -6. 3 times 3 is 9. And that's it. That would be your new point. Okay, so you're just following the pattern. Same idea with 7. We're going from 10 to 2 and -15 to -3. All right, again, it's always what are you multiplying by? So you might not be able to figure out what you're multiplying by right away, but if you notice, we're getting smaller. So you might think more like division. To get from 10 to 2, you're basically dividing by 5. And to get from -15 to -3, you're also dividing by 5. But since it's what are you multiplying by, this is the same thing as multiplying by the reciprocal. So we're really multiplying by 1/5. Is what we're doing, or dividing by 5 if you want to think of it that way. But if they ask you what's a scale factor, it would be 1/5. And so we do the same thing. Multiply by 1/5. 25 times 1/5 is 5. -5 times 1/5 is -1. And that would be our new point. All right, it should be getting smaller, which they are. All right, what is the image of the point -8, 6 after a dilation of 1 to 3? All this means is that it's getting 3 times bigger. All right, 1 to 3. So if you do 3 times bigger, -8 times 3 is -24. 6 times 3, you're going to get 18. And that would be your new point. All right, and 9 is very similar. What is the image of the point 12, -3? After a dilation of 1 to 5, that means that it's getting 5 times bigger. And so you multiply them both by 5. You'll get 60 and -15. And that would be your new point. Okay, so that's kind of how dilations work. This last part is, the next two problems are constructing the center of dilation. All right, you're going to need some kind of a straight edge. I have a bin of rulers that you're more than welcome to use. I believe it is under the table with the Kleenex on it. It's kind of under there. It's in a clear white bin, kind of the size of a shoebox. So if you need a ruler, please feel free to grab one. But basically, here's how it works. So you can also use your ID or something, a book or something. But center of dilation is super easy. All you're going to do is take a point at the top or close to the top of these images. So maybe like this part on her bun. And you're going to take a straight edge and you're going to draw a line and continue it as best you can. And then you're going to take a point somewhere on the bottom of the shape, so maybe her pointed right toe, and you're going to connect those together and keep going. And wherever those two lines intersect, that's going to be your center of dilation. All right, so center of dilation is going to be right there. All right, it's kind of out of that point that everything is kind of getting bigger or smaller. All right, same idea with number 11. There's this horse. You pick a point somewhere at the top, so maybe like his ear here, and then you connect the 2 points together and draw a line as best you can. And then you pick a point somewhere at the bottom of the horse, so maybe his feet or something. Connect them together, extend it, and that would be your center of dilation right there. All right, so that's our little constructions of dilations. And then this last question, all right. DEF, triangle DEF, this big triangle, is dilated to create triangle ABC. So from DEF to ABC, obviously it's going from a bigger triangle to a smaller triangle. So if it's getting smaller, that would be a reduction. All right, if it's getting bigger, it's an enlargement. All right, where's the center of dilation? I think all of the problems that you're going to see just kind of follow the dashed line, but you'll notice it starts right here at 0, 0. So you can either call it 0, 0, or if you want to say the origin, either one is totally fine. But that's where your center of dilation, I think, is going to be in 99.9% of the problems that we're going to do like this. Now it says, what is the scale factor? People always mess this up, so please make sure you know how to do this. Remember, we're going from DEF to ABC. So we want to know what we're multiplying triangle DEF by to get to ABC. So we're going to use one of the sides that actually has a number, so 18. We want to know what we're multiplying 8 by, so what's the scale factor, to get a new side of 3. So 18 times the scale factor is going to give me 3. Make sure that it's the triangle that you start with times s equals the new triangle. And then you divide by 18 and reduce. So the scale factor is 3 over 18, or 1/6. All right, people tend to mess that up and they have the reverse and they say, oh, it's 6, but it's not. So be careful with that. Okay, so the rest of the time is yours to work on the dilation section of the homework. So you're going to be working on 41 to 53. Do not worry about 35 to 40 or 55 because we'll do rotations tomorrow. As far as the homework that was assigned on Friday, the 21 to 34 and 54, if you didn't finish that, I know it was a busy homecoming weekend and stuff, make sure you work on that because tomorrow I will definitely be checking 21 to 34 and 54. All right, otherwise be working on 41 to 53. Tomorrow rotations, review Thursday, test Friday. All right, have a good day. Thanks.